Good day out there. Got an interesting one to look at today. This here is an axe handle lathe, also known as a duplicating or a copying lathe. But first, I'd like to thank you for your interest in old machinery, because without the support of everyone on this channel, there'd be no reason for me to keep publishing and showing off all this funky old machinery. So thank you. So this thing is a bit of a strange bird. It's an axe handle lathe, as I said before. Its design is to turn oblong things. It's a lathe, but with a stationary cutter, and you can make anything. You can make Jacobian furniture parts there with the spirals on them. You can make pickaxe handles that have a kind of an oval head. Any any sort of handle. These are most commonly kind of known for making axe handles, but I'll show you here in a minute. With this machine came the patterns for a sledgehammer, a pickaxe, a few baseball bats, which are kind of funny because you don't particularly need one of these machines to make baseball bats because they're circular. And it also came with 4 patterns for making wagon spokes. So the capacity of this machine is from the head here all the way to the farthest end of this piece, which brings it to about 5 feet, 4 or 5 feet. And you adjust the length by taking this whole tailstock equivalent, and it's just screwed to this top of this casting is dovetailed, so it can slide to whatever length. And then to actually mount your handle, there's a set screw and a hand wheel to do the fine adjustment. When you go ahead and put a piece of wood in here, the whole assembly, the whole carriage rocks back and forth. And it's kind of strange because without a piece of wood in here, there's nothing else preventing the whole carriage from keeling over and basically falling off the machine. So that's a bit of a strange element of the design. But anyway, you'd pull this handle back to where it is now, put your piece in. There are some spikes in the driver, I guess you'd call it, and then this is just a dead center on the tailstock end. And there is a rack gear here that you can tighten that piece in with. Now, I must say, one of the weirder things with this machine is its history, its provenance, because I really don't know much. It was sold by the Continental Machine Works or machinery company out of Montreal, who were mainly distributors, but one of my old 20-inch planers is marked with a Continental Machinery Co. Montreal right in the casting, so maybe they had some production runs done. Anyway, there is no maker mark on this thing anywhere. It is similar to the Ober lathes that are, in my opinion, the most common ones that you see out there, and the most common axe handle duplicating lathes, but it is not any of the models that they offered. It's got elements of a few of their different models. I guess the prominent feature of this thing is its lead screw. It runs the full length of the machine, about 8 feet, and it is a square thread lead screw, which the threads start about here and go all the way to the pulley at the end. Most of it is original, but there are no shortage of farmer fixes and janky elements to this thing. The whole tensioning linkage here looks like it's made out of scrap farm machinery and odds and ends. And there are guards that were made aftermarket, of course. And then the way that you engage this wheel is just a piece of, what is that, 1/4-inch pipe, 3/8 inch pipe. So it's quite strange. So let me go through its function for you. The thing hasn't run in probably at least 40 years. I bought it from some collectors in Franktown, Ontario, the McClellans, Al and Judy. Rest in peace to them both. Not many people did as much for restoring and saving all this old iron than they did, so thanks to them. This thing was used up in Ontario somewhere, and they were running it with a Wisconsin 2-cylinder engine. How it was set up, we'll probably never know. 2 counter shafts came with it, and the the cutter has a triple V-belt pulley, which is it would have been recut from a flat belt pulley. You can kind of see the profile with the 3 notches in between it. Anyway, let me go over the function of it. So at the far end, there's a wheel. This is the feed wheel or the drive wheel. It just idles until you pull this kind of very close to the fingers lever in here. You engage it, and it's kind of got a taper, and it locks that pulley. It slides it about a ½ inch, and then it locks into a collar on the end. So now, assuming that this is powered, the whole lead screw will begin to turn. When the lead screw turns, there is a keyway running the length of the lead screw, and that pulls this chain, and the chain goes up to a sprocket, and there are 2 more sprockets, or gears I think in this one's case, that drive the piece of wood and the pattern. One thing that's missing is a tensioner. There's quite a bit of slack in this, and it's quite noticeable when you start to spin this more quickly that based on the highs and lows of this profile, it'll go over a high spot, and when it gets to a low, it'll kind of hit it because slack will build up in the chain and then it'll release. And so that'll be no big deal, but definitely needs a tensioner added. Anyway, once you've engaged this and the wheel is spinning, you can see the whole carriage rocking back and forth now. But it's not feeding. So this is another Farmer Fix element. There are like 2 slightly offset pieces of 11 gauge steel, and there's kind of a cam that twists those both in, and those twist into the grooves of the lead screw. I just have a chainsaw file in here now. So if I kind of spin it until they line up with the groove, get them to drop in. Come on. Oh, there we go. Those have kind of dropped in, and now as I spin this and the pattern rotates, it's also pulling the carriage along. I'm not sure which direction would be optimal for it to move towards me or away from me. Oh yes, that's true. This collar here. So that means that it would be beneficial for the carriage to start at the far end, which is simply done by sliding it. If you disengage this, you can slide by hand the whole carriage to wherever you want it to start. This collar has a knob on the one side, and it just has a set screw, and you can tighten it to wherever along the keyway. You can see marks of them doing it. So presumably you set this to where the machine should stop, and when this thing is spinning, the lead screw is spinning, this knob will come up and it will knock this arm, which will throw the feed out of engagement automatically, which is a very nice feature, so you don't have to keep that close of an eye on it while it's running so it doesn't run the cutter into the end or something unfortunate. It's also got this drip oiler. This is just a red piece of plastic that's kind of in the place. Glass broke at one time, and it would presumably just drip some oil along here. And there is 1 support bearing. There are 2 bearings on either end, and one which is just like a half bearing in the middle, babbited, which runs on this shaft. The cutter back here is stationary. Some of the Ober lathes had a stationary cutter. Some, the cutter actually moved, and you need like a long cylindrical pulley to run that style. There's an arm which has some braze been built up on it, which is kind of your reference to the pattern. You should be able to move this arm in and out. There's 2 set screws, and that will kind of change the ratio from the pattern to the piece of wood that you're copying on. So if you were to move it out, let me think, I haven't gone through this fully yet. If you were to move it out, it would take less of a cut. So you could take multiple cuts until you'd get down to the final pass, or you could set it 1-to-1 and take all the material off at once. You just need to feed it a little bit more slowly. The cutters on this are another very strange feature. They seem to be handmade just out of bar stock, knife stock, and they're curved like a cup, and they pin through right down here. They bolt down here to the wheel, and they're just semicircular, and they're sharpened on the bottoms. And I don't know if these were left as a warning or as patterns, but hanging on it were 4 different teeth. So this one is, you can see how it was sharpened. It started about 1 inch, 1 1/4 inch thick, and as they sharpened it, it kind of ate away. Maybe this is a warning to not sharpen them too much because this one has broken off. So if you can imagine a little flying piece of knife in this kind of plane, that wouldn't be ideal. There's 2 more broken ones and 1 complete one. So maybe this is a progression of danger when you should replace the cutter. What else can we look at here? I think that's about it. It's simple. It's kind of it's a crazy machine idea, but it's not that complicated. Oh, so what has to be done to it? I mentioned there were 2 miscellaneous countershafts before, so I need the main power. There needs to be a high speed at the cutter, of course, and a very slow speed at the feed wheel. So I'll probably run this thing electrically because it's in the barn. I do have the Wisconsin engine that came with it, and it's in fine shape, but electric is just easier for the moment being anyway. Of course, this thing does deserve to go back to full line shaft power, flat belt run with an engine, or a water wheel or something lovely like that. I have a brute of an old Century motor or Peerless motor on the floor. It's 1 horsepower, but it's about this big, so it should have lots of torque for that. Yeah. What else can I say? I think that's about it. I need to make, oh yes, so that bearing is fine. That one's good. But the bearing on this end, they're just pillow block, Babbitt bearing pillow blocks, is not the right one for this, or it's missing a part because the diameter is fine, but it needs a 1/2 inch plate added. So I have that 1/2 inch plate, but the hole pattern is also off. So I brought a measuring stick, and this is just to get the hole pattern. So there's 6 inches between hole centers on the bearing, and if I slide it out of the way, there are 4.5 inch centers between the holes on the machine. So that means I'll need to drill holes in that bar and probably weld studs in, and that'll be the adapter plate. Ooh. Now that the carriage has been securely mounted, I've gotten pretty excited to try this thing out. So, Bing put a normal 110 plug on this, and this is a 110 or 220 volt motor. So if you look at the plaque on the top, it says 110 volts at 12 amps or 220 volts at 6 amps. 12 amps at 110 is no problem to run. I have that available here, so we're going to swap this to 110. It'll be easier. So if we look at the leads, wires coming into the box with these yellow morettes and then these two joined. The way this works in simple terms is you have two kind of winding segments. When you run it at 220 volts, they're run in series. So say power comes into lead 1, it goes out to 2, into 3, and then out 4. So you're running one coil into the other. If you want to run this on 110 volts, you power both coils at the same time. So we'll have 1 and 3 and 2 and 4 on the two leads here. So I'll go ahead and swap that over and then we'll test it out. I also put a new smaller pulley, smaller diameter. Where's the old one? Oh, there it is. So smaller diameter to get more speed out of the cutters and the correct spacing. This is for a smaller belt. That's for a larger belt like the ones that are already hanging on the machine. Well, that took a little bit longer than expected. Turns out the old switch shot the bed. It would just go flick, 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 do nothing. So that took a while to kind of troubleshoot. Anyway, no big deal. New one's in there, right current rating, so on. Here's the girl. She's 110, 220 at 12.4 or 6.2 amps. Repulsion induction motor. What that means is you have this commutator in the back and the brushes. That's your high torque starting mode. Once it's up to a certain speed, there's a governor in the front, very much like an engine governor. It's two weights, and once they get to a certain speed, they flick out and they ground out the commutator, if I understand this right, and they start to run induction with the coils inside. So if you want to see what I mean by that, I'll just step on it to give it a bit of support. Contact. There, so I'll shut it down. You'll see it'll slow, and it'll throw that out. There it goes. Now it's repulsion mode, which is for high starting torque, and once it gets up to its certain speed, it disconnects. Goes to induction. Repulsion is an unstable mode for a continuous speed, so it uses two different kind of techniques to achieve optimization over a different range of speed. So I built a base for the motor. You can see we're just running one V-belt, and the weight of the motor using shims underneath, well, shingles, tapered shingles actually, is giving a little bit of tension, constant tension on that belt. So presumably, because this collar is at this end, which acts to automatically shut the feed off once the carriage has reached a certain point, the carriage should start at the far end. So I've gone ahead and cut up a chunk of cedar. So this is nice and smooth, no knots. It's going to be an easy test piece, and if things go well, we'll have two nice pieces of ash, dry ash, to use. I've just marked the centers on both ends for the dead center there and the driver. I'll hit the switch for fun. You can see how absolutely quiet this thing runs. Right by my boot. Other than the noise of the motor, it's silent. So I'll put you on a tripod and we'll take our first cuts. Oh, also, I sharpened just by hand with a round file. I've sharpened to 5 cutters on there, very mildly anyway. That grab that just happened there, it was through the slack in the chain. So I'll probably have to make a tensioner for that right now. Try again. I think I was turning it the wrong way for the feed to be oriented properly. Taking a big cut. Well, that's interesting. We're unintentionally turning a spiral handle. That's because wood's too soft for the dogs to hold it properly. They're just tearing it up and spinning. So it's starting to go the profile. So the shape is good. The wood is quite rough, of course, and things seem to be operating okay. So I'm going to go ahead and process up that ash, and we'll come back and try with that. Let's try that again. So the piece of spruce was true 2x3. I had a piece of ash. It was 2x5.5, and I could have, if this thing was working perfectly, I could have taken a section, taken a cut right out of the center, and then would have wound up with pretty straight grain, but I wasn't quite that optimistic yet, and I wanted two testers instead of one. So here they are. I planed them down to 1 5/8 this time, and I think it's 1 5/8 by 2 3/4 approximate, I think a little bit less. Anyway, we'll see how this goes. And that is without taking any draw knife cuts across the top. We might have to do that. So you notice I just took the block off and put her back on. If you look at the edges, you can see where I manually went over them with a draw knife. This was my attempted fix for the corners rubbing on the cutter holder, kind of the cutter frame, and it was just rubbing and burning power unnecessarily. I did this twice, deepening the cuts on the second time. And this was a little bit silly because this is a machine. I'm not meant to take the blocks off and figure them out with a hand tool. So the second time around, this handle, I did end up completing it very slowly, taking a big cut with like one single operation. The second one, I adjusted the guide bar, or the kind of rubbing bar there, and took a light pass and then took a full one-to-one pass, and that did much better. And it turns out that with 2 passes at a fair rate, this is cranking the feed by hand, of course, I'm pretty confident that with an electric motor it would take 3 minutes on the feed, an electric motor on the feed, it would take 3 minutes per pass, so 6 minutes for a handle using 2 passes. Well, hope you enjoyed that bit of progress on that machine. It's one that's particularly special to me. Stay tuned for lots of tinkering, lots of improvements to be made, and experiments to be made with different patterns and different types of wood. So till then, hope you have a good one.